Welcome to Chapter 15. This lecture is going to be on decision analysis. So you'll be using decision analysis in your group case study. And as we've been saying throughout the course, the whole idea behind analytics is to make data-driven decisions. And this is beneficial because it gives the manager the opportunity for gathering information and facts and then basing his decision on a rigorous logical treatment of those facts. Risk analysis is also part of what we do in this business analytics, and that is where we use risk analysis to help provide the probability information about the favorable as well as the unfavorable outcomes that may occur. Decision analysis considers problems that involve relatively few decision alternatives and reasonably few future possible events. It becomes extremely complex if you get beyond that. And you'll see that when we go through the PDC exercise that's in Chapter 15. So the topics we'll be looking at in this lecture are payoff tables and decision trees, and then use of Bayesian probability. Part 1 will be expected value using payoff tables and decision trees. So the first step is going to be problem formulation. And we're going to work with our customers to create a conceptual understanding of the problem. And so that's going to start with a verbal statement of the problem. And then from that, we can start doing research into the problem domain and getting background information, understanding of the terms and the concepts involved with this particular problem. Then we have to look at the decision alternatives. So obviously, as we've been saying all along in the semester, we have variables that are we're estimating their future value, and so we don't know what their future value is. We have to estimate it, and therefore they're random variables. And in decision analysis, we refer to those as chance events. They can have different outcomes. And of course, an outcome is an association of decision alternative and chance event outcome. So an illustration that the book used was the Pittsburgh Development Corporation, PDC. And they're going to develop a property, and they've commissioned architectural drawings for 3 different projects. One with 30 condominiums, one with 60, and then one with 90. And the financial success of the project depends on the size of the condominium complex and the chance event concerning the demand for the condominiums. So the PDC decision problem is to select the size of the condominium project that will lead to the greatest profit given certain levels of uncertainty concerning the demand for the condominiums. So, given the problem, it's clear that the decision is to select the best size for the condominium complex. And so PDC has the following 3 decision variables. D1 is a decision to go with the small complex of 30 condominiums. D2 is the decision to go with the medium complex with 60 condominiums. And D3 is the decision to go with a large complex with 90 condominiums. So let's take a look at the worksheet just to familiarize ourselves with it. So here we see, and of course it's available to you in the resources, lectures, chapter 15, along with the PDF for the PowerPoint slides. So this is a model for the expected value approach to making decisions. You can use this as a starting point for your case study. In other words, the templates. Now you'll be doing a Bayesian analysis, and we'll be going through that shortly, but you'll still need to set up the arrows and the circles and the squares and the triangles. And of course, the circles, as mentioned in the text, are chance events. The squares are decision events. And in this particular case, we have 3 potential decisions that we can make. And then our outcomes are represented by the triangles. We'll go over the model in more detail. Let's just take a quick look at what happens though. So we've got a decision alternative, and as we mentioned, there's 3 decisions: small, medium, or large. And then for each we've got a chance event: strong demand for condominiums or weak demand for condominiums. For the medium, same thing. If we make a medium decision, we face the same chance event: strong or weak demand, and same with the large. So this is our setup for the worksheet that we'll be using for our decision model. So in decision analysis, there's different outcomes, same as with a random variable that we've been dealing with in our other business analytics all the way up through chapter 14. And the possible outcomes for a chance event are the states of nature. We might have called it a level of the random variable. The states of nature are mutually exclusive. No more than one can occur. And there's only one possible state of nature that will occur. So in the case for the condominiums, we've decided we're going to look at 2 states of nature. One is that there's a strong demand for condominiums, and the other is that there's a weak demand for condominiums. So one of the first things we're going to do is work with management to develop a payoff table for the condominium projects. And a payoff is the outcome resulting from a specific combination of decision alternative and state of nature. So for example, 8 in our payoff table is the outcome of strong demand and small project. So small complex D1 intersects with strong demand. 8 is our payoff for that, or the outcome. On the other hand, if there's weak demand, then for a small complex, our payoff's going to be 7. And the payoff table is going to show the payoffs for all the various combinations: small, medium, large, complex, strong, weak, demand. So we're going to have 3 decision alternatives times 2 states of nature give us 6 possible payoffs. as you can see, if we get more and more complexity, we're going to grow extremely complicated models, and those that tend to be very brittle. So the table we're looking at here in 15.1, let's take the 20. That indicates a payoff of $20 million will occur if the decision is to build a large complex D3. And we have a strong demand as the state of nature. Okay, let's take a look at our model again in Excel. And go over the states of nature, the probability for the states of nature, and our various decision alternatives. So let's look first at our decision alternatives. From our decision node, we've got 3 large, medium, and small branches coming out of that decision node. Each one of them faces a chance event or a chance node, and that's going to have a probability associated with the 2 states of nature. We've got a strong demand and a weak demand. So in H1, we have the probability that we're putting for strong demand for this particular scenario. Now, we're going to try different scenarios, but let's just look at the one with 80% strong demand, and that means that we're going to have a 1 minus H1, or 20% probability of weak demand. Because again, we're making these mutually exclusive, and if we have 80% chance for strong demand, then we'll have a 20% chance for weak demand. Now we have to repeat this 80% in each one of our decision branches, because we're going to be facing the same state of nature, and we want to compare the 3 projects using the same probabilities. So for H11, the probability is going to be equal to H1. So whenever we change the probability up top, right now it's 80%, that'll change the weak demands in all of our branches for decision, and it'll also change the strong demands as well. So here we see the weak demand is going to be equal to H6, referring back to this one, which in turn is 1 minus H1. Same thing down here. So this is how we get the different probabilities applied to each one of our decision branches. Let's look at A16. So what A16 is doing is it's selecting the maximum expected value for each one of the projects. So we see for the small project, the expected value is 7.8. For the medium project, it's 12.2. And for the large project, it's 14.2. So the maximum expected value of the 3 decision branches is 14.2. Now, how do we get those expected values? So let's take a look at our calculations here. You'll see in the formula bar we have an if statement. The if part is just to make sure that our math is close to being correct and that the probabilities all sum up to 1. And so we check to make sure that the difference between 1 and then the sum of the 2 probabilities we use for strong and weak is less than a very small number. And that means, for all intents and purposes, they do sum up to 1. So if that's the case, then we're going to do a sum of H1 times I4. So H1, of course, is the probability of the strong demand, and then I4 is going to be the outcome for strong demand and a small project. We get this 8 from our payoff table. So 80% times 8 is going to be 6.4. Likewise, our payoff for the other one is going to, if we come back to this, we're going to also add into that H6 times I9. So H6 is again the probability for weak demand. And we're going to multiply that by the payoff table for a small project and weak demand, and that's 7. So 0.2 times 7 is 1.4. And so when we add these two together, we're going to get the weighted average for a small project, or the expected value of the small project. That's going to be 6.4 plus 1.4, and that's 7.8. And we do that for each one of the three decision branches. Medium, we do the same thing. 0.8 times 14 plus 0.2 times 5, get 11.2 plus 1 equals 12.2, and so on. 8.8 times 20 is 16, and then 0.2 times minus 9, we subtract 1.8 from that, and we get 14.2. And again, A16, we take the maximum expected value of the three different project alternatives. Okay, so we'll go over the model some more, but first let's get back to getting some background knowledge on this whole topic. Pardon me. So we've been looking at a decision tree, and that's going to be a graphical representation of the decision-making process. And it's going to show the sequential progression of decisions and chance events that will play into our decision-making. And again, we've gone over looking at applying the results from our payoff table to the outcomes for each branch of decision and chance event combination. And so this is an abstract of what we were just looking at. And then, of course, we have put probabilities for them occurring. So these nodes, 1 is for our decision, 2, 3, and 4 are going to be for the chance events. The branches connect the nodes, and the branches leaving our decision node represent our decision alternatives. Branches leaving the chance nodes correspond to the states of nature, and the payoffs, or the outcomes, are what we get from our payoff table that we talked with management about at the beginning of our project process, when we're gathering facts and information. So let's finish up our look here at this worksheet. So now we have a model, a worksheet, that'll generate a decision on which project is the best based on various probabilities for strong and weak demand. So let's go ahead and put in a variety of different scenarios on what that demand could possibly be. So we'll put in N3, our expected value, equals a 16. And then let's say and we're going to make a data table like we have done earlier in the course. And let's say that we want to have our probabilities go from like 0.0, 0.1, and so on until we get to 1 on the other end. So now what we can do is look at, okay, what's the best decision if we have a probability for a strong demand going from 0 to 10%, 20%, all the way up to 100%. What is our best decision going to be for each one of those probabilities for a strong demand? So we've got this set up. Okay, so let's go ahead and create a data table for the expected outcomes for each one of our various probabilities. So we'll go ahead and select here, then go up to Data, What If Analysis, Data Table. Here we're going to use H1. In other words, we're going to put each one of these different probabilities for a strong demand up in H1, which drives the probabilities for strong and weak demand throughout our model, as we went over before. So I'll put in H1 there, and go ahead and click OK. And we can see that it then gives us for each probability the best decision. So 7 is going to be our small. So at a 0% probability for strong demand, it's going to be small. Of course, all of these are going to be small down through here we have small, 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 and then 7.7. So let's try that one. We'll say small and small, and then let's try a 30% here. So in this particular case, it's going to be a medium. Our medium expected value there is 7.7. So this is going to be medium. The next few will be mediums. Now, when we get up to 80%, of course, let's go up here, 80%, put that in. And here we get down, it's going to be the large. The best decision there is the large project, and we do that even up to 100%. So now management can see where the breakpoints are for small, medium, and large projects based on the probability they get for a strong demand versus a weak demand. So this concludes part 1 of chapter 15. We'll pick up with part 2.